bad trip. Ay nako, nakaka-bad. Oo, bakit ka bad trip? Ang dami kasi naming assignments, projects, exam, tsaka may reporting pa kami bukas eh. Okay na, kain muna tayo. Para mawala yung bad trip mo. Sige nga, baka sakaling mawala yung bad trip ko. O ano bang mga projects, assignments nyo at bad trip ka? Assignment namin, ang hirap eh. About electronics. Tapos may exam kami bukas about mathematics naman. Kung saan ba particular yung homework nyo at baka sakaling matulungan kita. Baka nga alam mo yun about photolithography. Sige, tutulungan kita mamaya. Kain muna tayo, ha? Sige. Lang ba yun? Okay lang yan. Sige. Salamat. Ay, busog. O, ayan. Nakakain na tayo. Siguro naman nawala na yung stress mo. Medyo. Sarap kasi ng luto mo eh. Bakit medyo lang? Eh, hindi pa ako nakakapagsimula sa assignment ko eh. Eh, medyo gabi na rin. Tara, tulungan na kita. Start na tayo. Explain ko na lang sa yung overview ng photolithography para magka-idea ka. Sige. Kung minsan, pag mag-aaral ka, tapos hindi mo alam yung topic, visit ka na lang sa YouTube. Kasi mas madaling mag-aral doon. Mas maiintindihan mo.
Ay, oo nga, madlaking tulong yan.
Ay, tulad nito, photolithography. Hanap tayo ng video na related sa photolithography. Ayan. So, makikita natin dito kung paano ba ginagawa yung photolithography.
Ano ba yung photolithography?
Ganito kasi yun. The purpose of photolithography is to deposit a masking layer of photoresist on a wafer. This layer defines the chemical pattern that will protect the underlying material from etching.
Ano bang process meron sa photolithography?
So, una, wafer cleaning. Before applying the photoresist, it is important to remove dust, dirt, and other contaminants from the wafers to avoid some errors and damages. Next is rinse and spin dry, which refers to the washing and removing the water and moisture in the wafer. Yun. Tapos, next is applying the photoresist. In applying photoresist, we must remember to apply photoresist evenly in circular motion. This is very important factor. Then, bake the wafer after applying the photoresist. So, yun.
Then, what is the next step?
Next is the mask alignment and exposure. So, masks are used as the master to produce the same pattern on many wafers. Masks are made of glass and chromium. Shining UV light through the mask exposes some of the photoresist. The photoresist that has been exposed can then be easily removed, leaving the unexposed photoresist on the wafer. So, before exposing, align mask and patterned wafer. Then, once aligned, expose to UV light. Then, we have the last step, which is to develop. We have to place the wafer in the developer to remove the photoresist that has been exposed to UV light after developing. Hard bake the wafer and then the wafer is ready to etch.
Nang matapos si Maris ng pagbibigay ideya kay Jessa tungkol sa overview ng photolithography, tumawag ang magka-dorm at magka-schoolmate sa kaibigan nilang si Jack sa Skype upang hingi ng video presentation nito na ipinasa sa kanyang propesor na tungkol sa resolution na may kinalaman din sa photolithography.
Now, we will be discussing resolution in photolithography. But first, we will define photolithography. Photolithography, also termed optical photolithography or UV lithography, is a process used in microfabrication. It is used to pattern parts onto a thin film or the bulk substrate of an IC or integrated circuit, and it uses light to transfer geometric patterns from a photomask to a light-sensitive photochemical or photoresist. Now, we will show you the picture or an example of photolithography. This is the resist, which is the integrated circuit which has a silicon dioxide and a UV light source. There we will pattern geometric patterns using light. Yeah. And again, resolution. There are limits in photolithography and this is limits for imaging. The ability to project a clear image of a small feature onto the wafer is limited by the wavelength of the light that is used. Current state-of-the-art photolithography uses deep ultraviolet light or DUV light from excimer lasers with wavelength of 248 and 193 nanometers. But in the current trend today, this photolithography allows minimum features of up to down to 50 nanometers. The formula in calculating the limits of resolution in photolithography is CD is equal to K1 times lambda over NA. We will show you the formula now. This is the CD, which is the minimum size, and K1 is the coefficient that encapsulates the processor's related factors and typically equals 0.4 for production in regular productions. Lambda is the wavelength of the light used, and NA is the numerical aperture of the lens as seen from the wafer.
Pagkatapos turuan ni Marie si Jessa tungkol sa overview ng photolithography at pag-aralan ng video presentation ni Jack, siya ay nakatulog na ng mahimbing at handang-handa na para sa kung anumang topic ang i-assign sa kanya ng propesor para i-discuss sa klase bukas. At ang topic na napunta sa kanya ay depth of focus.
In this video, we will cover a concept called depth of field or DOF in short. So let's say we have a camera here, we got our lens, and in this area where the camera can see, now in this area we might have a tree and maybe some apples, and we are actually to photograph the tree. The distance of the tree is the area we want to focus, so this area is called the field. What we are interested is the depth of this field. We want to know how we can control it. We want it deeper and shallower. So we have our film, lens, and we have our subject. When this camera focus in tree, that means that light in the tree is going to hit the lens and then focus back onto the film. So that means that this point of the tree is getting refocused perfectly back to this point of the film. It just means that everything in this point along the line can be refocused perfectly in the film. This point here that we're focused on, as we are going close to it, it gets more and more focus. And as we get farther away, it becomes out of focus. As the light spreads apart, it's getting out of focus. There is a limit here in both sides that we consider that it is in focus. Now, what we want to look at is how to control the depth of field and achieve different sizes of depth of field. The right side will serve as in focus, and the left side will be out of focus. Since the camera as in the right side, if we want a wider depth of field, we need to make that the light is not spreading too much. We have this area around this point. As the light spreads out, we have a limit here. Consider the area in focus. Consider this area as a toothpaste. So this is its squeeze right here. If we are to squeeze this area, we will end up a line that look like this. So what will happen is that the toothpaste is squeezed up and this will be the area.
Sa paghanga ng kanyang mga kaklase sa kanyang galing, ay pinalakpakan siya pati na rin ng kanyang guro. Dahil sa husay niya, siya ay binigyan ng pribilehiyo upang pumili kung sino ang gusto niyang mag-discuss ng tungkol sa masks for photolithography.